All right, so notice that your assignment today is in Delta Math, but there's a 2 there, because there are 2 Delta Math assignments. The reason I didn't put them together, one of them is titled the same thing the notes are, just like it always is. The other one is a review of completing the square. It's a way to factor things, okay? And it's a review. Today we're converting coordinates. Tomorrow we're converting equations, and we have to complete the square. I'm not reteaching you how to do that because, like I said, it's a review. So I would suggest that you do that one first before tomorrow. It wouldn't make any sense if you did it after tomorrow. It shouldn't take you that long. If you know how to do it, you should be able to fly through it. Okay? If you don't know how to do it, then this should refresh your memory. It does a good job of stepping you through it, so it's not just, hey, do this and complete the square and you don't even know what it's talking about. It makes you fill in the things, and just like anything else in Delta Math, there's videos and there's examples and stuff if you don't remember. If you've done it before and you can do it before, then after you see a few quick ones, you should be able to fly through it. They're easy. Okay? We good? And if not, then you should be relearning it, learn it, I guess. I don't know. All right. So we're going to convert polar and rectangular coordinates. So we're going to start up here above where the notes actually start first. And then draw, oh my goodness. Why do I always do that? Okay, so we're going to start up here, draw a little X and Y axis, and we're going to draw a triangle in the first quadrant. We know that this is X, this is Y, this is R, this is theta. So we're not dealing necessarily with just the unit circle. It's just a circle, so R isn't always 1. It could totally be 1, but we don't necessarily know that to begin with, okay? So from this, what we do know, though, is we've known this for a long, long time, that x squared plus y squared would equal r squared because that is the Pythagorean theorem. Okay? We also know that for the unit circle, our x value is cosine, but this is not the unit circle, so I'd put x over r for cosine. So the cosine of theta is x over r, and the sine of theta is y over r, and the tangent of theta is y over x. Okay. Make sense? Sound familiar? Okay. So if I want x, which like I said, x isn't just cosine because we're not dealing with unit circle, I'm going to multiply both sides by r. So x equals r cosine theta. Y equals r sine theta. This is where your mg cosine theta, mg sine theta comes from in physics. Does that ring a bell? Maybe? Sort of? It brings back trauma. I'm sorry. I apologize for making you relive the trauma. Okay. So given point P, see, and it wouldn't have been quite as traumatic had you learned all this stuff first, but that's not the way these courses work. We try to traumatize you. It's on purpose. So given point P with polar coordinates r theta, so we know that's how polar coordinates work, the corresponding rectangular coordinates x, y are given by, well, this is where your x comes from. So x equals r cosine theta, y equals r sine theta. Okay. So we're going to convert each pair of polar coordinates to rectangular coordinates. So this first one here, this is in the form of r theta. Okay, we're going to change it to the form of xy. Okay, so we're going to start, actually the first thing that we're going to do is we are going to plot that point. It's over here. It's a polar coordinate, so we're going to plot point 2, 5 pi thirds. So I'm going to go to 5 pi thirds, which is right here. 2 would be right here. And I'm going to label that number 1. Okay. All right, so then we're going to go back up here. So we're going to find x. That is equal to r, which is 2, times the cosine of theta, which is 5 pi thirds. Okay, so x equals 2 times, what's the cosine of 5 pi thirds? 1/2. So this is 2 times 1/2. So x equals 1. Okay, everybody okay with that? Then we're going to do y. Y equals 2 times the sine of 5 pi thirds. So y equals 2 times, what's the sine of 5 pi thirds? Very close. Negative. Good. It's negative. Negative square root of 3 over 2, which means that y equals negative square root of 3. Okay, so my ordered pair that I end up with is 1 negative square root of 3. And this is xy. So we're going to plot that one on the xy coordinates, but I'm going to give you the estimates. Square root of 3 is about 1.7. Okay, so I'm going to go to 1, about negative 1.7, which will be right about there. And if we laid these two graphs on top of each other, those points would just match up exactly. Because remember, these are two different ways to get to the exact same place. Just two different routes. Okay? We good? What questions you got? Okie dokie. So this is r theta. Let's find x. X equals, oh, let's plot that too. I'm sorry. Negative 6, 3 pi fourths. So I'm going to go to 3 pi fourths, which is right here. Negative 6 puts me right here. This is number 2. Which tells me, now you don't have to plot, we're going to plot them every time on the notes so we can see what's happening. You don't always have to plot these points when you work these questions, but if my point is here, then I know when I'm done, my point has to be in the 4th quadrant. Kind of helps me make sure my answer is at least in the right quadrant. So, all right, so we're going to do x equals negative 6 times the cosine of 3 pi fourths. So x equals negative 6 times cosine of 3 pi fourths is negative square root of 2 over 2. Very good. And so that means that x equals a positive 3 square roots of 2. All right, so then y is equal to negative 6 times the sine of 3 pi fourths. So y equals negative 6 times, good, square root of 2 over 2, and it's positive this time. So that means y is a negative 3 square roots of 2. So my ordered pair is 3 square root of 2, negative 3 square root of 2. So 3 square root of 2 is about 4.2. So I'm going to go to the right. 1, 2, 3, 4.2 down 1, 2, 3. Oops, not right there. It's about right there. I wanted to do it in the same color so they matched up. Let me undo that again. That's number 2. So they should be in the same place. Okay. Any questions about that? All right. You're going to do number 3 on your own. But let's go ahead and we'll plot this together. I go to negative pi halves. So here I am at negative pi halves. Negative 1/4 means it's on the other side of the axis. So it should be right about there. That's number 3. All right, you go ahead and find your x and y values here. When you're done, check yourself up here. Let me know if you have any questions. We all good? Okay, so I'm going to plot this point on my rectangular coordinate grid. So 0, 1/4 is about right here, which is the same position that one is. We good? Any questions at all? Okay, I don't think we need to do number 4, so we're going to go to the back. We're going to start above where the notes start again. So one of the things we wrote on the front, we got from our triangle, but we didn't use, was x squared plus y squared equals r squared. Okay? So I'm interested, we know how to find x, we know how to find y. If I want to find r, I can take the square root of both sides, so I can say that r equals the square root of x squared plus y squared. What did I leave off of there? Plus or minus. Yet I'm not going to math jail because this is the radius, and the radius is always positive, so that was a conscious thing to do there. It's not a plus or minus because it's always positive. Okay? Make sense? Because the radius is just always a positive number. And then we know that we dealt with sine and cosine on the front, and we wrote down tangent, but we didn't do anything with it. Tangent of theta, sorry, my brain is, equals y over x. So I need to find theta. That's going to be the tangent inverse of y over x. Okay. So it says, given a point P with rectangular coordinates. So I have x, y coordinates. X and y is something that I know. I want to find the polar coordinates, so I need r and theta. This is how I find r. R equals the square root of x squared plus y squared. And theta equals the tangent inverse of y over x. Okay, everybody okay with all that? So this is in an x, y format, and we're going to change it to polar. So we're going to plot that point on our rectangular coordinate grid. 2 square roots of 3 is about 3.5. So I'm going to go to 2 and then 1, 2, 3.5. That's number 5. The other thing that we need to know, since we're changing it to polar, is we need to know what quadrant we would be in on the circle. Well, I'm in quadrant 1 here, so I'll be in quadrant 1 down there. So I'll make a note of that. That's something I need to know for myself. These instructions say, convert each pair of rectangular coordinates to polar coordinates. If theta is between 0 and 2 pi, give 2 possible solutions. So what we did in 6-1A and what you did on your quiz yesterday gave you 1 polar point, and you gave me 3 more for a total of 4, right? But we were going from negative 2 pi to 2 pi. That's why there was 4. We're only going from 0 to 2 pi, so there's only a total of 2. That's why it's asking for 2. And going from 0 to 2 pi, all of your angles have to be positive. Okay? So let's go ahead and convert. And I know I'm going to end up in the first quadrant here. So I'm going to have r equals the square root of x squared, so that's 2 squared, plus 2 square roots of 3 squared. So r equals square root of 2 squared is 4, plus, what's 2 square roots of 3 squared? 12. So you get 4 plus 12, which is the square root of 16. So r equals 4. So then I need theta. Theta is equal to the tangent inverse of y over x. So that's 2 square roots of 3 over 2. So that's really just the tangent inverse of the square root of 3, right? So theta, when is tangent square root of 3? Pi thirds, and I'm in quadrant 1, so pi thirds is what I want. Okay. So one answer is 4, pi thirds. So I'm going to plot that point, and then we'll talk about what the other one would be. So we're going to go to pi thirds, and my radius is 4, so 1, 2, 3, 4. I'm right here. This is number 5, and you can see that they're in the same position. I'm in the first quadrant, just like I thought I was going to be. Now, my angles can only go from 0 to 2 pi. So if I want my other coordinate that lands me here, I'm going to have a negative radius so that I land over here and go through the pole, right? So if this is in the first quadrant, this is the third quadrant. What's my third quadrant pi thirds angle? 4 pi thirds. So my other point will be negative 4 pi thirds. Because I would go to 4 pi thirds and then pass through the pole to get to the 4 over there. So these are my two answers. Questions about that? About where anything came from? Or what's your question? That means my angles are from 0 to 2 pi. Those are my only options. Okay. We're trying to make it harder than it is? Okay, we'll stop doing that. Okay. Now let's look at number 6. This is in XY form again. Since it's in XY form, we can figure out the quadrant before we ever even graph it, right? What quadrant is this point going to be in? 4th. So this is in quadrant 4. All right, so let's go ahead and plot that. It's a 3 squared roots of 2 over 2 is about 2.1. Okay. So that means I'm going to go to 2.1, negative 2.1, about right there. And this is number 6. All right, so we're going to start by finding R. R equals the square root of 3 square root of 2 over 2 squared plus negative 3 square root of 2 over 2 squared. So what's just 3 square root of 2 squared? Just the numerator. 18. And then so I'd have 18 over what? 4. What's 18 over 4? 9 over 2. So I get 9 over 2 plus, this is going to give me the same thing, and because it's negative, when I square it, it becomes positive, so I have 9 halves plus 9 halves. So that's just the square root of 9, so R equals 3. Then I'm going to find theta. Theta equals the tangent inverse of y over x, that's negative 3 square root of 2 over 2 over positive 3 square root of 2 over 2. So that looks horrific. I could keep change flip, but are the numerator and the denominator the same with the exception of the sign? Then what does it reduce to? Negative 1. So I really have theta equals the tangent inverse of negative 1. So I know that tangent is 1 at the pi fourths angles, and it's got to be negative, and I'm supposed to be in quadrant 4, so what's my fourth quadrant pi fourths angle? 7 pi fourths. Very good. Okay, so my ordered pair is 3, 7 pi fourths. So I'm going to go, y'all go ahead and I'm going to go answer the phone. You go ahead and plot it and find your other point. Okay, so I'm going to plot this. Hopefully you already have yours done. I'm going to go to 7 pi fourths, which is over here. My radius is 1, 2, 3. Okay, that's 6. Those are about in the right spot. Okay, so my other point is going to have a negative radius. What's the angle going to be? 3 pi fourths. Very good. Okay. Everybody okay with that? We good? Okay, awesome. You do number 7 on your own. I will give you the graphing though. 0.9. So square root of 3 over 2 is about 0.9. So we're going to go to negative 0.9, negative 1/2. About right there for number 7. check yourself with me when you're done. Let me know if you have any questions. Probably really should have put 7 pi 6 right here, but I got to this point before I realized I didn't check which quadrant I was in, so I was like, oh dang, I gotta go check that. So really, the theta that I get from all this is 7 pi. This is alpha, it's your reference angle, but then this is the angle I actually wanted because of the quadrant. What questions do we have? Anything? We good? How many Delta Math assignments do you have? 2. Do you want to do the one that goes with this first or the one that does completing the square? Completing the square. Do that one first, okay? And you have some time left, so do that now.